Okay, I'm going to jump on down to 52. I think in between there was the exponential and the logarithm ones that we just tested over. So I'm going to go on to 52. If I have time, I'll come back to the logarithm ones. But I do want to do these because we haven't done these in a while. So these are our square roots. So remember, in order to solve a square root problem, we do the opposite, which would be to square both sides. And since this one has radicals or square roots on both sides, then both will cancel. And so this one, you're only left with just what's underneath the radical, and therefore we have as just an equation that we can solve. So I'm going to go ahead and move the 9x this way, and then move the 1, and then divide off. Okay. And the key would be to go back in and double check to make sure you're not getting a negative under the radical on here. But since x is a -1, that is going to turn this piece into a +7. And so this works out okay. The same way on the other side, that would also work. Okay, 53. Now the difference in it is there is not a square root on both sides, just on one side. But the rule is still, we still have to square both sides. So this side will give me just 4, where these will cancel. And now we're going to solve. Okay, so the first step is kind of the hard step. The rest of it then becomes a review. Again, double check that, but 2 times a -9 is a -18, plus 22 is 4, and it does work. Okay, 55 would be the next one that would be very similar to this one. Okay, and again, if you recognize that this is the square root piece of it, that's kind of my function I'm looking at. And so also that this is a multiplication between these two. So we're going to take care of the add and subtract first. -18, and then get rid of the -2 because that's multiplied. And then our final step is to do the reciprocal power. So we're going to take this to the 3 halves to both sides. Okay, so 2/3 times 3 halves, that cancels. I'm left with 2m plus 13. And then on this side, what this again means is our power over our root. And so I am going to take the square root of 9 and then cube that number. Okay, so the square root of 9 is 3, and 3 cubed is 27. Slide this on up. So 2m equals 14, divide by 2, m equals 7. Okay, so that's how those would work. I'm going to go ahead and do 56 and 57 real quick. They are just rules of exponents, which we're working with exponents here. And you just have to remember all of your rules. Okay, so what I always do is if there is a power to a power, in other words, this piece here, I'm going to do it first. Okay, now don't forget everything in here needs to be taken to the 4th power. Okay, so first I'm just going to rewrite my numerator. I'll deal with those negatives up there in just a minute, but I'm just going to rewrite this, do one thing at a time. So I'm going to take 2 to the 4th, so that would be 2 times 2 is 4, times 2 is 8, times 2 is 16. Then I need to do power to a power, which says to multiply. Okay, so I'm using this rule, let me read that, do that again. If I have xm to the n, then it's xm times n. That's what rule I'm using, which would give me 4. And then 4, or the n, 4 times a negative 1 would be a negative 4. Okay, so that's all I've done is just take care of this piece first. Okay, so the next thing that I'm going to do is I want to take care of the rule that says x to the negative 1 is 1 over x, or if you want to think of it, 1 over x to the negative 1 is x. So they're just the flip of it. So basically, if it is in the numerator negative, I take it to the denominator. If it's in the denominator negative, I take it to the numerator. So we're just going to kind of flip it over the bar. So here, if you need to, go ahead and put powers on everything. Okay? So the 2 is to a positive power, it stays. The 3 is to a negative, so it's going to move. The 2 is negative, it moves. I'm just going across. This first 2 is positive, and the m is positive. Okay, I'm going to do the same thing in the denominator. The 16 is positive. I can put that wherever. I'll go ahead and put it out in front. The m to the 4 is positive, so it's going to stay. The n to the negative 4 is negative, so it's going to go up. Okay? The rest of it is just combining. So 2 times 2 is 4. Let me go ahead and get this here. And then in your denominator, again, the rule is, well, should I keep putting m? If you have x to the m times x to the n, then it's x to the m plus n. Okay, so I am going to be taking my m's and putting them together. So I have 7 and then 2 of those. Okay, my next rule that I want to be applying is that if I have x to the m divided by x to the n, then I subtract. Okay, so we're going to take each one of these separate. So first, 4 over 16 is just fractions. So that's 1/4. My next one, I am going to do my m's. Okay, so there is 1 in the numerator, 7 in the denominator. So I can look at it one of two ways. I like to just subtract 7 minus 1 is 6, and then I just look at it. And I see that there's more in the denominator, so my 6 needs to go here. Now, if you're following the rule over here, it would be 1 minus 7, which would be m to the negative 6. That's in the numerator, so then I would have to write it in the denominator, okay? And then I'm going to do my n's the same way. I have an n4 and an n2. So 4 minus 2, always do bigger minus smaller, is how I do it. That's a 2, and I just look, and 4 is bigger than 2, so it goes in the numerator. Final answer. Okay, so let me do 50. Was that 50? I said 57, but that was 56. That's my bad. So 57. I feel like my pen's stopping. 2 to the 4th times 2 to the negative 2 times 2 to the 4th squared. So just like what we did before, I always do the power. In this case, now if the whole thing was to the power, I wouldn't necessarily do it. But since I just have one little power thing, here I am. So I'm going to take care of it first. You don't have to do it in the order I do it. I like this better. So 4 times 2 is 8. Okay, now I'm going to take care of the negative rule. Again, if it is negative in the numerator, it goes to the denominator. If it's negative in the denominator, it goes to the numerator. Okay, so start here. This is negative, so it's going to go down. There's nothing on the top right now, so I'm just going to put a 1 right there. Okay, this is positive, it's going to stay. This one's negative, so it's going to go up. And this one is positive, so it stays. Okay? And now I'm going to combine them. Oh, excuse me. So 1 and 4 is 5, and 8 is 13. Those are all to the base 2, so I just leave that. Now I'm going to do my my subtraction rule. Whoops. And so 13 minus 2 is 11, and I have more on the denominator, so I'm going to put that there. Now, at this point, there's nothing in the numerator, so we have to put the 1 there to hold it, okay? And that would be your final answer. Okay, so that's kind of the rules with exponents.